Hello guys, welcome back to Techdose, and in this video we will see the synchronous versus asynchronous programming, which is from the basics of system design. Let's take a simple example and try to understand this. Let's say that Sam and Pat are good friends and Sam is going to cook bread toast. So Sam is asking Pat, it is sending a question to Pat, will you have bread toast? Now Pat can answer as yes or no, okay? And there is a constraint to it. The constraint is Sam will only eat with Pat. This means that Sam will cook bread toast only if Pat says yes. Otherwise, he will not cook it. If that is the given condition, then Sam will ask his question at this point and he will be waiting until he receives an answer from Pat, and based on the answer, he can start cooking. He may not start cooking or he can start cooking, but this is the waiting time which Sam has to wait until he receives answer from the Pat, and this is the time Pat is thinking. Okay, the first point here is when Pat actually receives the question, and this is the one point when Pat makes up his mind and sends the answer to Sam, right? And in between time is the thinking time taken by Pat. So after asking the question and waiting for some time, when he receives the answer, if the answer is positive, let's say yes, then Sam will start cooking, and let's say the cooking is done at this point, then both Sam and Pat can have their bread toast at this point of time, right? Now in this case, you see that there are two events. The first event is the event of making the toast by Sam, and the second event is if Pat wanna eat the toast. Now according to the constraint, you can make out that making the toast by Sam and if Sam is gonna eat the toast is actually two dependent events. Right? Why dependent? Because Sam will make the toast only if Pat is going to eat, because Sam want to eat with Pat only. He will not eat alone, right? That is why it is a dependent set of event. In such a case, if two events are dependent, then such kind of events are called synchronous events. Okay, we call such events as synchronous. Now let's change the constraint. Let's change the constraint to say that Sam will definitely have the bread toast whether Pat is going to have it or he doesn't gonna have it, right? So then what Sam will do is Sam will send the question again to Pat, asking if he wants to have the bread toast. But then do he need to actually wait until he receives the answer from Pat? If you think carefully, then the answer would be no, because he can start his preparation right at the time of asking the question, and he can prepare his own bread toast. Okay, he can prepare his own bread toast, and as soon as he receives the answer from Pat, if he receives no, then his job will be done till this point only. And if he receives a yes, then he can also make bread toast for Pat and may be done even before time, right? So in that way, two events like making the toast by Sam and the answer given by Pat are not dependent. Okay, Sam is anyway going to make the toast because he wants to eat himself, and just as a courtesy, Sam was asking Pat. So these two events are not dependent. So in case if the events are not dependent, we can categorize them under asynchronous events. Okay, I think this clears out dependent and independent events and how they are related to synchronous and asynchronous event. Let's take a technical example. I would like to announce about our live training programs, data structures and algorithms, which is interview dose, and system design, which is design dose. If you are looking for making a switch from service to product based, or even make a product based to product based top tier switch and aiming for your dream company, this is the best curriculum you can ever join. I'll be your mentor throughout the cohort, and I will help you clear all your doubts in the one-on-one sessions. You can know more about this by querying us on the WhatsApp number, or you can also visit our website techdose.co.in. Let's consider an e-commerce application like Amazon application, and let's say that we had searched for soap, since we are gonna buy soap, and we are seeing n number of results with a few information about each of the products, soap 1 to soap n. Now let's say we are interested in this soap 2, and so we clicked on this soap 2, and after clicking on this, we will see the detailed item catalog, right? Where you will have a photo of the soap, a bigger picture, and maybe you will have multiple pictures and video recommendations. And then you will be seeing item details, a lot of details about dimension, weight, and quality, ingredients and many other things. You will also see the reviews. Okay, so all these things are present into the detailed item page, which is meant for SOAP 2. Let's say we clicked on SOAP 2. Now in order to show this detailed page, we have two types of information here. The one type of information is text and another type of information is photos, right? Let's say they are kept at two different places in the databases, and so taking the photo and taking the text will be two independent events. Okay, so let's say the time to load the photo is 0.1 second and the time to load the text details is 0.1 second. So if we are doing this one by one, like once we will load the photo, then we will load the text, or let's say once we load the text, we will load the photos, then the time to retrieve the text plus the time to retrieve the photos will be added and you will get all the details in 0.2 seconds. But since they are independent, right, the photos do not depend on the text because they may be kept at two different places, and so we can parallelly retrieve them. And if you parallelly get the photo and the text, then you will do the same job in 0.1 second. How did we get 0.1 second? It will be the maximum time of 0.1, 0.1, because you are doing parallel operation now. So you can create two different threads. One thread will get the photo, another thread will get the text, and then you can combine the result, right? So in a synchronous process for this application, you will be taking 0.2 second, which is done by just using a single thread, and using asynchronous process you will be doing it in 0.1 second. So in this case asynchronous process will be faster because these two events, event of getting the photo and event of getting the text details, are two independent events, right? Now let's quickly compare the synchronous and asynchronous events. The synchronous type is actually a blocking architecture, because if you consider the example of Sam and Pat, then Sam only wanted to eat the bread toast with Pat, so making the bread toast by Sam dependent on the answer given by Pat, right? So they were two dependent events. So after asking the question, Sam was waiting for the answer from Pat so that he will decide on whether to start making the toast or not. So this waiting stage is actually the blocking stage, right? Sam is blocked to get an answer from Pat. Okay, so this is a blocking architecture. While if you consider the non-blocking architecture where Sam was gonna eat whether Pat eats or not, then Sam will start making the toast as soon as he asks the question because he is going to eat for sure, right? So that is a non-blocking architecture. There is no waiting time involved there. Okay, we are doing parallel processing. So we can do this with multiple thread. One of the thread will actually be waiting for the answer receiving from the Pat, and another thread will actually prepare the toast. So there are two threads involved, while in the synchronous type architecture we will ask the question, that is Sam will ask the question and the same thread will wait for the answer. As soon as it receives the answer, then it will start making the toast. So only one thread is involved in case of synchronous, while two threads are involved in case of the asynchronous architecture here. We have understood that synchronous is blocking architecture while asynchronous is non-blocking architecture, and also synchronous is single threaded while asynchronous can be multi-threaded. If you consider the synchronous type programming, then you can always serialize all the events and make them work for both dependent and independent type events. How? If you consider the second case where Sam is going to eat the bread toast whether Pat is gonna eat or not, then Sam could have waited and could have started after getting the answer, and still he will be able to make the toast. But the only thing is there will be a waiting time involved, and so the time taken to get the bread toast ready will be larger. So if the events are not dependent, then why to wait? Let's start as soon as we know that we have to make it, right? So just to make it more efficient, we go with asynchronous process if the events are independent. Otherwise, with synchronous process, you can solve whatever is the constraint. Okay. Now, again, in the Amazon app example, you could have taken photos and items one by one, that is serially, but that will take you 0.2 second. Yeah, that is completely fine. So synchronous works, but then why to wait for 0.2 second when you can get the job done early in 0.1 second? So asynchronous actually makes the entire operation faster by doing parallel operation. Okay, but asynchronous can only be applied for independent events. For dependent events you cannot apply it. Okay, now point 3 actually leads to point 4, that Since there is waiting time involved in synchronous, so you can expect low throughput. And since there is no waiting time involved, there is parallel processing happening. So for asynchronous, you can expect higher throughput. Synchronous is always easy to code. Okay, there is no complex coding involved, while asynchronous involves complex coding with multi-threaded environment, and hence handling scenarios are important. You can get your code buggy at any point of time. I hope you were able to understand the comparison of synchronous with asynchronous type. Like and share our video and subscribe to our channel in order to watch more of these system design videos. See you guys in the next video. Thank you.